Hello, this is Mrs. Grizafi. It's 11.03 today for pre-calc. We're going to review our rationalization technique first, and then we're going to be looking at some piecewise graphs where we're finding the limits of those. Then we're going to start to get into our difference quotient, which is a big part of calculus. So rationalizing technique. First, of course, we always try to do direct substitution here. So I'm just going to show you real quick off to the side using direct substitution and see what happens. So I'm going to take whatever my limit is approaching, which is a 0, and sub that in everywhere I see a y. So that's rad 5 minus rad 5, which is 0 over 0. So I get my indeterminate form. So whenever I get the indeterminate form, I need to try something else before I can do direct substitution. So whenever you have these radicals being added or subtracted, we want to rationalize or multiply by the conjugate. So we're going to multiply the top and the bottom by, and I'm going to just erase that right there for now. I'm going to multiply it by rad 5 plus y plus rad 5. So exact same thing that's on the top. It's just that the sign between them changes to a plus sign. The sign under the radical still stays the same. I'm going to put this in parentheses, and now I have two binomials on the top, so I'm going to need to FOIL those. So rad 5 plus y times rad 5 plus y, write out limit as y approaches 0, will give me 5 plus y. Then we have rad 5 plus y times rad 5. So that's going to give me 5 times 5 plus y. They're both under a radical, so they can be combined under the same radical. The next, the inside's going to be the same thing but subtraction. And then my last terms is negative times a positive, so that's a negative. Rad 5 times rad 5 is just 5. And I want you to try to keep your denominator, keep it in factored form. It will help you a lot later on. I know I mentioned this last time as well, and it just saves you a little bit of work if you keep your denominator factored. All right, so now looking up here, I've got like terms here and here. My 5 minus 5 will cancel. So now, and again, you should be writing out that limit as y approaches 0 each time. I'm left with y on the top over y times the square root of 5 plus y plus the square root of 5. Now I can cancel those out because they're both attached with multiplication. Again, write out that limit. So there's nothing left on the top, so that's a 1 over rad 5 plus y plus rad 5. Yes, there are radicals in the denominator, but that's not what we're concerned about. We're concerned about being able to use direct substitution and whether or not we get that indeterminate form. So now let's try direct substitution. So everywhere I see a y, I'm going to put a 0. So I get rad 5 plus rad 5. Well, this is good news. And we just have a 1 on top. So now I have 2 rad 5. Here's where we don't want to leave the radical in the denominator because it's our final answer. So we multiply by rad 5 over rad 5. Rad 5 times rad 5 is 5. So my final answer would be radical 5 over 10. So the limit as y approaches 0 of that expression, we're getting closer and closer to rad 5 over 10. So just a little bit tricky because there are so many radicals in there. I thought it would be good to go over one more of those together. Okay, number 2, finding one-sided limits. So here's where we're looking at these piecewise graphs to see a one-sided limit. Find the following limit graphically and algebraically. So let's start with graphically. We're looking for the limit as x approaches 1. So you'll notice over here we have x is less than 1, x is greater than 1. So when we did these in class, and then you've done these in Algebra 2 and Algebra as well, I just like to break them up into two different equations. So f of x equals 4 minus x for the first equation. And the second equation is f of x equals 4x minus x squared. And I'll do a table for each one. So this one, my domain is restricted to where x is less than 1. So I'm going to start at 1. Even though it's not included, I always start at the number that's given here. And then I always circle it and say, okay, well, it's not included, so I know I'm gonna have an open circle there. And we want x is less than 1, so I'm going to go down. So 0, -1, -2. I can tell by looking at this right here that this is going to be a line with a slope of -1 and a y-intercept of 4. So I know I only need a few values here. So 4 minus 1 is 3, 4 minus 0 is 4, 5, and 6. If you needed to, you could also put that right into your calculator. Over here for this table, we're going to again start at 1, but this time we want to go bigger than 1. Also remind myself here that it's going to be an open circle because it's greater than 1, not greater than or equal to 1. And let's just go up a little bit here and see what happens. So 4 times 1 is 4, minus 1 is 3. And again, you can use your calculator to do those as well. And let's graph and see what we've got going on here. So let's do this first one in red. I've got the point 1, 3, 0, 4, -1, 5. And that I know is continues going up. And actually this should have been an open circle at 1, 3. And it continues that direction. And then this other graph here, actually I'm going to label that first. So f of x equals 4 minus x. And then we've got 1, 3, again, an open circle. 2, 1, 2, 3, 4. 3, 1, 2, 3. And 4, 0. And you can kind of see here, we should know by looking at this, it's a parabola. And it's negative x squared. So it's going to open downwards. And it's going to continue as x gets greater than 1. So that's what our graph should look like. Now let's talk about the limit. So the limit as x approaches 1. So from the left-hand side, our y value is approaching 3. And from the right-hand side, as we go towards that green line, we're approaching 3 as well. So the limit as x approaches 1 of f of x, graphically, we can see is going to be 3. Now let's talk algebraically. So forget we did all those tables. We're just looking at this given equation here. So since we were talking about the limit as x approaches 1, we want to find the limit from the left-hand side and the right-hand side. So I'm going to do from the left-hand side, I do a little negative. So this is the left-hand limit of f of x. So if I want to go from the left-hand side, I want where x is less than 1, because that's coming from the left-hand side. So just like on our graph, the red side is where x is less than 1. So that's where we're coming from if we're coming from the left side. So I'm only going to use that equation to find the left-hand limit. So I'm going to do the limit as x approaches 1 from the left of 4 minus x. So I'm just going to sub in, use direct substitution. 4 minus 1 is 3. Then I'm going to do the limit from the right-hand side. So my right-hand limit as x approaches 1. So that would be a positive because we're coming from the right. So that one, we want to choose the equation where x is greater than 1 because we're coming from the right side. So we're going to do the limit as x approaches 1 from the right of 4x minus x squared. And then use direct substitution. So 4 times 1 minus 1 squared. 4 minus 1 is 3. And since these are the same, therefore, we know the limit as x approaches 1 of f of x must be 3, since they're the same. If they were different numbers, then we would say it does not exist because the left-hand limit and the right-hand limit aren't the same. So 2 different ways of doing this problem, graphically and algebraically. Algebraically is probably a little bit faster, easier, but I wanted you guys to see the connection to the graph and why that works the way it does. So really make sure you take a look at that graph before moving on to number 3. And for number 3, I would like you guys to pause the video and give it a try on your own. And this one you're doing algebraically. Okay, so hopefully you tried this now. You've got x approaching 1 again. So notice we've got where x is less than or equal to 1. That's going to give us our left-hand limit. as x approaches 1 from the left. So we're going to do 4 minus x squared, and then do direct substitution. 4 minus 1 squared is 3. Let's see if we get 3 for our right-hand limit. So then we want to find the limit as x approaches 1 from the right side. So now we're looking at where x is greater than 1 because we're coming from the right side. So that's going to be this expression, 3 minus x. Use direct substitution. 3 minus 1 is 2. So these are not the same. They're not equal. So the limit of f of x as x approaches 1 does not exist. Why? Because the left and the right hand limits are not equal to each other. So if you don't get the same thing for the left side and the right side, there does not exist. They're not approaching the same number. They're approaching two different numbers, where on the last one, number 2, they were both approaching 3. So then it did exist. It was just 3. And lastly, a limit from calculus, our difference quotient. So this is your difference quotient right here. And we're going to talk more about this as well and taking the limit as we move on after this. But after this lesson, you guys will be having a quiz coming up on the limits stuff. So I will post that for you as well. All right, so for number 4, we want to find the limit as h approaches 0 of f of 3 plus h minus f of 3 all over h, given that this is f of x. Okay, so a lot going on here. First, I want to find what f of 3 plus h is. So I'm going to go to f of x, and everywhere I see an x, I'm going to replace it with 3 plus h. So I'm going to take out my x and put 3 plus h there. Okay, so now I want to expand this. So I'm going to write 3 plus h out twice. FOIL that. So I get 9 plus 3h, so that's 6h plus h squared minus 1. Combine my 9 minus 1 to get 8. I'm just going to rearrange it in standard form. So h squared plus 6h plus 8. So that's f of 3 plus h. Okay, so that's the first thing. That's this right here. Next, I want to find f of 3. So I'm going to do that over here. So f of 3, everywhere I see an x, I'm going to replace it with a 3. So that's 9 minus 1, which gives me 8. All right. So now I want to rewrite this. And then I'm going to replace the green circle, the f of 3 plus h, with this right here. So I'm going to have the limit as h approaches 0 of h squared plus 6h plus 8 minus my f of 3. My f of 3 was 8, so I'm going to put in an 8 right there, all over h. Okay, now let's combine our like terms and see where we can go from here. So now my 8's like they're going to cancel. Now it looks like I have a GCF in my numerator, that of h squared plus 6h, so I'm going to factor that out. And now I can cancel out my h's, which leaves me with the limit as h approaches 0 of h plus 6. And now I can do direct substitution, sub in my 0, 0 plus 6 is 6. So all of that, kind of cool, that the limit as h approaches 0 of f of 3 plus h minus f of 3 over h, if we know that this is f of x, this is the function, x squared minus 1, then that limit as h approaches 0 will be 6. So a lot of different steps here. So it's a lot of work to get to that answer, but take it step by step. So first we found f of 3 plus h, then we found f of 3, and then we put those in, we put this in for f of 3 plus h, 8 in for f of 3 back into this original, into the green circle and the blue circle, subtracted them, and then just simplified from there. And that's how we got our 6. And we will be doing more of work with that type of format as well coming up in a few classes. All right, I hope you're all doing well. Miss you. I hope to see you soon. Pie out.